Right, so the first type of stoichiometry that we're going to talk about today is mole to mass stoichiometry. Last time you would have learned mole. That was the easiest of all the types of stoichiometry. It only really involved two steps. It involved the given and then the ratios. For this one, you're going to notice that now we add an additional step. So if we look at the top right hand corner, we have the given. That would be our step 1. We have our ratio. That's our step 2. And then we have the molar mass, that's our step 3. Okay, so let's go ahead and start first by determining the mole ratios. So to determine the mole ratios, I want you to find the two compounds in the question. So I'm putting the star next to the question. That's our question. We're going to read it. And you're really finding the two things that look like chemicals, or what some of you might call that, but we call them chemical substances or chemical formulas. So the first one that I see is H2O. And then the second chemical formula that I see is NH3. So we know H2O is water. I'm not sure if you know this, but NH3 is ammonia. So now that you found them in the question, what I need for you to do is now find them in the balanced equation. So if you have H2O, I'm going to look for H2O here, but I'm going to circle it with the coefficient, and you'll see why. And so for the NH3, I'm going to find it, and I'm also going to circle it with the coefficient. So now that I have those two things, I'm going to create that ratio that'll look a lot like a fraction. Because I had you circle the coefficient, that's for the reason of stating that it has 4 moles of ammonia and 6 moles of water. So I don't want you to get away with just writing the number. Don't just write number 4 and that's fine. You have to always write two things after numbers. You're going to write the unit, and the unit here is moles. And then you're going to write the substance, which is NH3. Okay, now that I have that done, I'll write the next one, or the other substance we found, and it's 6 moles of H2O. Okay, so it's 4 moles of NH3 per 6 moles of H2O. So that's our ratio. Now all we have to do is flip it around, so we have options. So 6 moles of H2O, and then right underneath it, we have 4 moles of NH3. Okay, so we have that done. The molar mass step we won't do until we get started with the problem, and that'll lead us to figuring out which molar mass we have to find. Okay, so let's go ahead and start with step 1. So step 1 we said was the given. So the given is always the only number in the question. So if you read the question, you're going to read blah, 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 you know, letters, letters, letters. Yes, you'll see that subscript too, but I'm talking about like true numbers within it, which is at 2.20. So it's not going to be just enough to put 2.20. Remember, after every number, you've got to have a unit, which we know is moles, and a substance, which is NH3. So we're going to write 2.20 moles of NH3. Okay, now that we have our given taken care of, let's look at our second step. And then our second step says ratio. So we know that that's the first thing we did. So we're going to pick the ratio. But there's a simple process to picking the ratio, and I'll show you how to do it. If you look at your given, there's a reason why I always have you write the unit and the substance, because that's going to tell you what to put diagonal. So if you forget what the word diagonal means, it means, well, at an angle and to the bottom. So if that was moles of NH3, that means diagonally it will also be moles of NH3. So that now that you know that what goes on the bottom, take a look at your ratios, take a look at your first option and your second option, and find the one that has moles of NH3 on the bottom. So the first option has moles of H2O, so that's not something we're going to use, but the second option does have 4 moles of NH3. So we have our 4 moles of NH3, and up on the top we have 6 moles of H2O. Okay, since these units match, we're going to cancel them. And the whole purpose behind canceling them is getting rid of them until you get the last unit that you don't cancel, because that's the one you want to have in your answer. And that's always going to land on the top last box in your dimensional analysis. Okay, so As we go on with the problem, we've canceled those and we're left with moles of H2O. But notice that we still have an additional step after that. So we're going to do the same process we did with the given, where we put the unit and the substance diagonally. So I'm going to put the unit and the substance diagonally. And then we should probably see what is the step that's next. And it says molar mass. So now we need to find the molar mass. Remember I said that we won't do the molar mass until we find out of what? So since we wrote this diagonally, now we know that we're going to find the molar mass of H2O. So for H2O, there are 2 moles of hydrogen and 1 mole of oxygen. Hydrogen, on the periodic table, its mass is 1.01 grams, and for oxygen, it's 16 grams. So when I multiply that, that's 2.02 grams, and then I multiply 16. 1 times 16, that's 16, and I add them together, 18.02 grams per mole. So this is going to sound weird, but now we're going to go ahead and divorce the grams and the moles. So here's 18.02 grams, and I'm going to divorce it from the moles. What this means is that for every 1 mole of water, it weighs 18.02 grams. So what we're going to do is we're going to separate it and make it into a fraction. So I'm going to put it up here. I'm going to put for every 18.02 grams, that is equal to 1 mole of water. Okay, so looking at what we just wrote, let's see how it will play out in that next step. So since we have moles of H2O on the bottom, we're going to go ahead and put the number 1 next to the mole, because that's what's next to it in our molar mass. And what's on top is going to be our molar mass, which is 18.02 grams. And it's still going to be the same substance, H2O. Notice that when you'll do ratios, the substances will be different. And when you do molar mass, you'll notice that the substances will be the same. So H2O and H2O on the top and bottom, and for ratios, it'll be two different ones that you see in the problem. So now that I have that, I'm going to go ahead and cancel them diagonally. So I have moles of H2O canceling with moles of H2O. So now the last step is really just to calculate your answer. So remember, we have the number 2.20, the number 6, and the number 18.02. Because they're side by side to each other, you multiply them, and we'll put them on the top. So it'll be 2.20 times 6 times 18.02. Okay, all that will be divided by whatever you have on the bottom. So since we have a 4, we can multiply it by the 1 that's next to it. And we know 4 times 1 is obviously the same thing. But now what you're going to do is multiply all the top numbers, and then multiply all the bottom numbers, and then divide simply the top number by the bottom number. And once I do that calculation, my answer is going to be 59.47 once I round it to the nearest hundredth. So 59.47. I can't leave it to where it doesn't have a unit and a substance. Remember, every single number in your work will have a unit and a substance. Don't forget that we didn't cancel this. So that's what goes behind the answer. And if you notice what the question was originally asking us, it was how many grams of water. So we should be really answering that question, that many grams of water. Okay, so this is how you do a mole to mass problem. So now I'm going to show you how to do mass to mole, which is very similar from the one we did just right now. The only thing is you're going to notice that the steps are just switched. Okay, so this one will go a little bit quicker. How do we know it's a mass to mole? So go ahead and take a look at what your given is. Your given is in grams. So if our given is in grams, the unit is mass. Or I'm sorry, the unit for mass is grams. So we're looking for mass. And then what are they asking us to find? They're asking us to find moles. So this is a mass to mole problem. Always start with the given and then end up with what you want to find. The important thing about knowing what type of problem it is so that you know what your setup. This is what I'm calling the setup, which we used in the earlier example. So that tells us what steps we should take. So this one has one step, which it starts with your given, the second step, which is your molar mass, and the third step, which is your ratio. And that's how many little sections we have. So just like before, what we're going to go ahead and do is we're going to start by finding our mole ratios. So you look at the substances that are mentioned in the question. You've got O2 and you've got CO2. Now that you identified those, find them in the balanced equation with the coefficient. So you've got 5 moles of O2, and then for CO2, you've got 3 moles of CO2. Now that you have that, put them in a fraction. Don't forget to put the word mole or unit mole in between. So you're going to put 5 moles of O2, and then on the bottom, you're going to put 3 moles of CO2, and you're just going to simply flip that ratio so you have an option to pick from. Okay, I've got my ratios done. That was pretty quick and easy. So now I start with the actual setup. Okay, so the first step is to write the given. So the given is the only number in the question. So if I go back to the question, it says 125.50. So I'm going to write 125.50 because I've been telling you, don't forget the unit and the substance. The unit is right behind it and the substance is also right behind it. So it will be grams of CO2. Okay, the next step we had to do, if you recall, is we took whatever it was that our unit and substance that was in our given, and we wrote it diagonally in the next section. So that means that diagonally should be grams of CO2. If you notice your steps on the top right hand corner, it says your step is molar mass. So in the past example, if you remember, your step was ratio and then molar mass. But this one, it flips it, because rather than giving us a given that was in moles, now they're giving us a given that is in grams. So we'll find the molar mass of CO2 because that's the one being mentioned. So up here on the top, we've got carbon dioxide. For 1 mole of carbon, that's going to be multiplied by 12.01 because that's the mass on the periodic table. We have 2 moles of oxygen. We're going to multiply it by 16 because if you look at the periodic table, it's 15.999, but we round it to 16, which is the nearest hundredth. So we do the multiplication. 1 times 12.01 is 12.01. 2 times 16 is 32 grams. And then when we go ahead and add them, it's 44.01 grams per mole, which is the unit for molar mass. Don't forget, we're going to divorce the 2. So it's going to be 44.01 grams per 1 mole. So now that we've divorced the 2, we're going to come down here, and if you look, this bottom section says grams. Because it says grams, the 44.01 is the one that's going to be placed right next to it. So 44.01 goes next to that, and then the 1 mole is going to be right above it. And don't forget, always the unit and the substance. So after a number, unit and the substance. So now that we have that, we can go ahead and cancel our like units. And just like we did it on the other problem, the other type of problem, we take the unit and the substance from the previous step, and then we just make sure that it's placed bottom and diagonal to that one so it can cancel. So since it was moles of CO2, we'll put moles of CO2 down here. And looking at our notes, our next step is ratio. So we know we already did that part. We just have to figure out which ratio we're going to use. Are we going to use option 1 or option 2? So the reason we had to write this, or we wrote this, is to make it easier to understand what's going on. Since this is moles of CO2, you want to pick a ratio that has moles of CO2 on the bottom. Okay, option 1 is the only one that has it on the bottom. Option 2 does not. So I'm going to go ahead and cross that out to show that I'm not using it. And so all I'm going to do is write what I see for option 1. So on the top part, I see that it says 5 moles of O2. And then on the bottom, it says 3 moles of CO2. Okay, now that I have that done, I can cancel my like units. So remember, this was purposely placed to match that. And then these two had already canceled from before. And the unit that I did not cancel, the unit in substance, is moles of O2, which if you look at the question, it's asking for moles of O2. So we know we're doing the steps right. Okay, last step is to get all the numbers and multiply them together. If they're on the side, or side by side, I'm sorry, you will multiply them together, and you do the same to the bottom. If they're side by side, you multiply them together. Once you get that top number and that bottom number, you divide them to get your final answer. All right, so once we do the calculation on the calculator, it comes out to 4.75, and you have to remember to put the unit and the substance for every number you use in the assignment. And there you go. That's how you do a mass to mole. So again, very similar to what we did in the last problem. Okay, so now it's going to be your turn. You are going to be expected to do 4 practice problems. Now that I've shown you how to do a mass mole and mole mass, now your job is to look at the notes that you just took on how to do those and follow along. What I will do is I'll go ahead and do the first one. I would like for you to go ahead and pause that portion of the video, you try it, and then play it to see if you did it correctly and see what you may have done right and wrong, and that way you learn from that experience. So I would pause it here. Let's go ahead and get it going. Okay, so first, you're going to go ahead and figure out what type of stoichiometry is this. Okay, so type of stoichiometry, we're going to find what is our given. So our given is over here and it says moles. So our given is moles. And they want us to find how many grams. So grams is a unit of mass. So it's a mole to mass problem. Okay, so if you start looking at your notes, once you write everything down and you have the setups, that's going to allow you to find out, oh, that's the work I have to do. That's the setup. So for a mole to mass, remember it was given as your first step, ratio as your second step, and molar mass as your third step. Okay, so we always started with, after that, we went ahead and did our ratios. Okay, we circled the substances that were given to us. So it's NH3 and NO. So then you go to the balanced equation after the question and find the NH3. Make sure you put the coefficient, and then you have to find the NO and make sure you put the coefficient. Okay, now that we have that done, now we can create our ratios. So we know that for 4, and don't forget to put the word or unit moles, for 4 moles of NH3, we have 4 moles of NO. And all we have to do is flip it around. So for every 4 moles of NO, we have 4 moles of NH3. Okay, our ratios are done. And when the molar mass is always the thing we wait for to find out which substance we need to get the molar mass for. So now we're going to do step 1 in the dimensional analysis, which is the given. So the given is always the only number in the question, 4.32 moles of NO. So 4.32 moles NO. Remember that you take your unit and your substance and you copy it diagonally, just like you did in the practice. So there it is diagonally. Let's look at our first step. Our first step is ratios. So That means that I'm going to pick a ratio that has that unit and substance on the bottom. So we know the first option has it and the second one does not. So we're not going to use the second one. We will definitely use the first one. So on the top of the ratio in the first option, it says 4 moles of NH3. And on the bottom, it says 4 moles of NO. Okay, so now we're done with step 2. Step 3, if we look at our setup, it's molar mass. So just like we did before, we're going to go ahead and cancel our like units, get rid of them. We're left with moles of NH3, but what we're going to do with that is copy it diagonally, like what we did with the given. So this will be moles of NH3. Okay, so now the question was molar mass of what? Now I know it's of ammonia, NH3. So we have 1 mole of nitrogen and 3 moles of hydrogen. So nitrogen, the mass on the periodic table is 14.01 grams. And for hydrogen, the mass is 1.01 grams. So when I multiply those two, you have 14.01. And when you multiply the bottom part, it's 3.03. So as my molar mass, it's going to be 17.04 grams per mole. And don't forget to divorce your molar mass. You divorce it by putting it separately. You'll put 17.04 grams per every 1 mole of a substance, or that substance, ammonia. So now that I have that down, I look at the setup. Notice that I have the unit moles. So since that has moles, I'm going to put the 1 next to it, and then the 17.04 right above it. Don't forget, this is grams of the same substance. Okay, so now we know that we can cancel ammonia with ammonia, and we're going to be left with grams of NH3, which if you notice the question, it does state grams of NH3. Okay, from this point on, we're going to go ahead and multiply the numbers. So you would be multiplying 4.32 by 4 by 17.04. So let me write it on the bottom. So 4.32 times 4 times 17.04. Those are all the numbers that are side by side to one another on the top. And you do the same thing to the bottom. 4 times 1. Okay, I'm not going to calculate it since this is part of your task. I'll go ahead and let you do it. Make sure that you complete the other 3 and make sure that you are following your notes.